will now do electrostatics, problem number 8. And in this problem, it says a negatively charged rod is brought near the top plate of a charged electroscope. So the first thing I'm going to do is draw an electroscope that's charged. So here's an electroscope, metal rod down through the middle, attached to a conductive ball, and a charged electroscope would have the two leaves at the bottom spread apart because they both have the same charge, and that's what causes them to spread. And it says now that as the negatively charged rod is brought near the top plate of a charged electroscope, the vane first collapses. So now that we have this electroscope, and by collapses, that means they're no longer spread apart. So now my electroscope, with that negative charge brought near, now has the leaves that are not repelling each other. So here comes my negative rod. So we go from step 1 to step 2. Then it says, as the rod is brought nearer the top knob of the top knob, the vane diverges again. So moving on, now I look at my electroscope. Here's my electroscope again. As the rod is brought nearer, negative charge rod, that it actually diverges now that it's closer. It says, explain the behavior of the electroscope vane, use a sequence of diagrams, which I've done, and name the kind of charge on the electroscope. And that would be the charge to start. So in sequence number 1, we have a charged electroscope. So we start off with a charged electroscope. We don't know the charge. But we know in the second picture, when the rod is first brought near the electroscope, that it's always brought near the top knob. So electrons in this electroscope are actually being driven downwards. Now, when the leaves are collapsed, like here, this means that there is a neutral charge on the electroscope. So that means the electrons and protons now equal each other out. So in the first case, now, what we know is bringing down electrons causes a neutral charge. So that means it had to start off as being positive. Now when electrons are driven down, it becomes neutral. And as we bring this rod closer, it repels. Remember, like charges repel. It repels and forces even more electrons out to the vanes, causing even more negative charges to go to these leaves at the bottom, which then would mean there's a negative charge here at the end. So what happens here? Our electroscope started out with a positive charge across the entire electroscope. Then, as the rod was brought near, electrons are driven out of the top, which does leave a positive charge in the ball at the top. But we're really looking at the leaves when we talk about the charge. It drives electrons down into the leaves, leaving me now with a neutral charge in the leaves. That's the only way that the electroscope collapses. And finally, as we're bringing it even closer, even more electrons are driven down in the electroscope, causing a negative charge to be on the leaves.